Hello students. Let's say we want to find the subsets of 1 through n. So what do I mean by that? Okay, well, the subsets, let's start with some examples. Let's say the subsets of 1, 2. Let's say we want that first. Well, what would that be? Well, let's not try and make a set of subsets, right? But let's try and make a list of subsets. Well, I could include nothing, I could include 1, I could include 2, or I could include 1, 2. And these are the 4 subsets of 1, 2, the set 1, 2. The empty set is always a subset because, to check to see if it's a subset, you check to see if everything in the set is in the set 1, 2, and since there's nothing in the set, there's nothing to check, it automatically passes. Okay. Let's say I wanted to find the subsets of 1, 2, 3. Well, any subset of 1, 2 is going to work. That's going to be a subset of 1, 2, 3. But also, I'd have 3, 1, 3, 2, 3, and 1, 2, 3. And these are the subsets of 1, 2, 3, the set 1, 2, 3. Now, if I'm looking at this, I see, hey, I have 4 of them that have 3 in it and 4 of them that don't, right? And I have 8 total options for the numbers 1, 2, and 3. Well, one way to think about that is either 1 is in the subset or it's not. Either 2 is in the subset or it's not. Either 3 is in the subset or it's not. So basically we have 3 choices, each with 2 options, or 8 possibilities. And you'll see we've gotten a list with 8 different subsets in it. Also note that we use this to denote the set with no elements. And you could even check how many elements are in this. None. So that works nicely. Okay. But you know what? Since the last 4 options here were the same as the first 4 options with 3, what could I do to get these last 4 options without having to type them all out? Like, let's say I wanted to extend this, but now I want to write, I want to add 4s. So I have all of these sets, and I also want each of these sets with a 4 in it. Okay. Well, one thing I could do is I could say, okay, give me the collection of all sets in here. That would just spit out the sets again. Oh, S4S in. Very clear message there. Okay, so what I could do is I could union these with the set 4. So that's the union symbol. And the and sign is for intersect. The pipe is for union. So now I've gotten these sets here, which are these sets with a 4. And if I really wanted to find all the subsets of 1, 2, 3, and 4, what I could do is I could say, okay, let's take this. And since they're lists, we add them. And then I could do this. And I get all of these as our possibilities. Okay. Well, this is actually looking to me like something that we can do with recursion. Why? Because I can get the subsets of 1, 2, 3, 4 from the subsets of 1, 2, 3, and the subsets from 1, 2, 3, I can get the subsets of 1, 2, 3 from the subsets of 1, 2, and so on. So it looks like we can build upon the last object to create the next one. Okay, well, let's try this. Subsets n. Okay, and what do we want to return? Well, first of all, let me just say, what happens in the case of 1? What would the subsets be of the set that just contain 1? Just contains 1. What do we got? Well, we would have the empty set, and we would have 1. Those would be the subsets of 1. So let's return this if n is equal to 1. Otherwise, okay, well, what do I want to return? So in order to get the subsets of size n, what I want to use is I want to use the subsets of size n minus 1, the last one, just like we could use subsets of 1, 2 to get the subsets of 1, 2, 3, and the subsets of 1, 2, 3 to get the subsets of 1, 2, 3, 4. So here I want to use the subsets of 1 through n minus 1 in order to get the subsets of 1 through n. So first of all, we have the subsets of 1 through n minus 1. And now what I want to do is I want to take each of those subsets and I want to stick n on the end. Just like we stuck 3 on the end of the subsets of 1, 2, and we stuck a 4 on the end of the subsets of 1, 2, 3. So let's try that. Let's say S for S in subsets of n minus 1. However, that's just going to give me the same thing twice because I haven't unioned it yet. So let's union that with n. Okay, and let's talk about this. Let's make sure we understand what's happening. If I want the subsets of just a set containing 1, what it's going to do is it's going to give me that. Otherwise, what it's going to do is in order to find the subsets of the set 1 through n, it computes the subsets of the set 1 through n minus 1, computes all of those. Then it takes those again, but it tosses n onto the end of each of those. And then it puts them together with this plus sign. Okay, well, let's see if it works. Maybe it doesn't. Hopefully it does. So let's try the subsets of 3. You'll see I got exactly what I wanted. And the subsets of 4, meaning the subsets of the set 1, 2, 3, 4. That's what my subsets function does. This should produce the subsets of 1, 2, 3, 4, and it does as well. Suppose I wanted to start at 0 instead of 1. Like I could do subsets 1, but if I try subsets 0, well, that's not going to be good. You see, why is that not going to be good? Because in order to get subsets of 0, it's going to try to get subsets of minus 1. And to get subsets of minus 1, it's going to try to get subsets of minus 2. And it's going to go, and it's going to go, and it's just going to keep running and running. And eventually it'll realize that, you know, it's stuck. Well, here, Jupyter gave me a message saying that it sort of overstayed its welcome in that computation. Okay, but how could I fix the issue? Well, let's go back here. And what would the subsets of the set of size 0 be? That's the set of no elements. Well, the set of no elements is a subset of the set of no elements because every element in the set of no elements is in the set of no elements. Trivially, there's nothing to check. So if I wanted to change this, what I could do is say, okay, if n is 0, I have those brackets there. And let's try this. Subsets. Subsets of 0. And that gives me just the empty set. If I want the subsets of the set of 1 element, it still works. 2 elements still works. So this is working for all values. Now, one thing I often say is, you know, it's not all the time, but quite often, the trickiest part of any recursion is actually the base case. It's that stopping case. Because I can understand some people might be tempted to just do this. They might say, okay, well, if I want the subsets of the set that has no elements, that's just going to be the set that has no elements, right? But this is wrong. It's wrong for a number of reasons. Because what we're trying to do is we're trying to return the collection of all subsets of the set 1 through n. This is not the collection of all subsets. This is the only subset. Right? So this should be giving me a collection of subsets, and it's not. It's just giving me that empty subset. What happens if I try to run this? Let's say I try to get subsets 2. And I get a very clear error message here. It's saying it's trying to add a set to a list. It tells me right off the bat, you know, we're doing something, we have the wrong types here for doing addition because I have a set and I have a list. Well, what's happening? Well, what's happening is when it tries to go get the subsets of the set of containing 1, it's taking the set, which is supposed to grab the collection of all the subsets of the set that has no elements, but instead it's actually grabbing the set because I forgot to put these brackets here. So it's trying to add a set to this list over here. And that was what went wrong. And how do I fix that? Well, I fixed that by doing what I had before. So that's a nice example of recursion. Some things to keep in mind is what we needed to do in order to make this base case work. Another thing is just recognizing that this is actually quite easy to do with recursion. And that comes from the fact that we could answer the question for n if we knew the answer to the question for n minus 1. Whenever you're in that kind of situation, you want to consider recursion as an option.